Just to give you a little bit of background, this didn't start off really being about amateur satellites or space or anything, and started a little over a year ago. As probably a reasonable number of you know, the UK has crossed the tipping point where the number of engineers that we generate is smaller than the number of engineers that our industries want. And my working assumption is that's a disaster. That's a national disaster. And I used to whine about this. And instead my chum Margaret said, "Gary, why don't you get off your fat backside and do something about it?" And I said, "Is it fat?" And she said, go, come with me to Warwick University. We'll get some student volunteers to help you and we'll do something. And that's how this actually started. So, the original working title for the activities is Robo-Duino, simply because I use a piece of technology called an Arduino, and robotics is something that does interest kids. The idea of being able to make a remote control or an autonomous little vehicle actually seems to interest children. I'm aiming at teenagers because they're kind of the lost generation. There's a humongous amount of work goes into primary schools in science and technology, but there's much less goes into teenagers. And that's partly because teenagers and adults, there's a tension. You know, they don't necessarily get on quite as well as maybe adults get on with primary school children. And teenagers are quite resistant to doing stuff that adults do for many natural, hormonal, and psychological and social reasons. But I just felt like, I'll give it a crack. The worst I can do is just annoy half a dozen teenagers, and I actually might make a difference. So that's the focus. 12, 14, 15-year-olds. So I'm going to introduce you to some of the goals, talk about some of the technology, talk about some of the projects, and my plans for the next 6 to 9 months, and then I'm going to just beg for some help. Okay? So you have to sit there even during the begging bit. So my goal is not to have teenagers just consume technology, because that's easy. I mean, I can consume pork pies all day until my heart gives out. That won't actually make a tremendous amount of difference to our lives in the world. We actually have to figure out how to get larger swaths of people to understand the impact of science and technology so that we don't leave it to a bunch of not terribly competent people to run the country. And we have to instill in them the idea that they can do this. You know, it's different. It may not be what you thought you could do, but it's interesting, and you might end up being world famous, making scads of cash, and being able to knock off from your entire life's working part by the time you're 25. My inspiration was the Imagineering Web charity, which has about well over 100 clubs for primary school children. And one of the genius ideas is, not only do they make technology things like micrometers and telescopes and spring balancers and water detectors, they teach 8-year-olds how to solder, which is a great thing in my opinion. Hell of a health and safety problem, but there we go. They've figured that one out. But the kids keep everything, and so they take it home and it goes in the closet, and years later it gets pulled back out, and they take it into school and say, "I know how a telescope makes because I made one. I know a little bit about this gravity stuff. I made a spring balance, I remember that." And so the idea of that is to lay in children's minds something which actually hangs around in the house and they tell their parents or relatives or friends about. And so it's not simply an observational activity like watching someone else play a computer game. It's something that you're involved in, and you get a little artifact to remind you about this. And I think that's a stroke of utter genius. To do it, though, they have to pitch this at £1.50 per hour per week per child. And they get companies to pump prime them. So they have a toolkit, costs less than £100, and then they get a set of kits for 12 children, volunteer engineer, and that engineer goes and works with a teacher in a class, so they've got crowd control with them, and they go and build this stuff and have a pretty rich set of materials and kits. So that is my inspiration. Fabulous bunch of people. You know, I'm going to will everything I have to them. So I'm trying to replicate that idea for teenagers. Now, by the time you got to a teenager, I don't believe making a are going to go for simple mechanical stuff because they have iPods and mobile phones and things. So it has to be a much more sophisticated piece of technology to even seem like something on par with what they're doing. Robotics was the easiest thing to do in a way because it's quite different from what they get in school. And my target is if we can get it to about £2.50 a week per child so that their parents go, okay, I get an hour of childcare for £2.50 every week, so I can have an hour doing something interesting. And actually they get stuff and they learn stuff. Why would I not do that? Now the Imagineering Web have been so successful that they have had to have lotteries in schools because the kids who walk home never get into the Imagineering Web club because the kids who get picked up from the school gate hand over the form, can I go to this? Their parents sign it and run back into school. That's how popular it is because it's such an easy calculation. You cannot get an hour of childcare for £2.50 anyway. So it's very simple economics. Now, it's always, I worked with a pretty sophisticated marketing guy, and he always said it's very useful telling the team what the non-goals are so they don't invent arbitrary constraints. I have no goal for anybody to make my kit. I don't give a flying fig. What I do want them to do is figure stuff out. So I have to give them enough raw material, and I have to give enough raw material so not me can be in the room with them and get some success. And that's what I'm trying to build now. I'm quite happy to use Lego, Create, and all kinds of stuff. I've got a kit here from a guy called Stuart Dunn who invented this construction set called Create. And I can get stuff like this for a couple of pounds per person to make things. I'm not trying to sell stuff. I don't care if they don't buy it off us. That's fine, but we'll have something as a fallback. I don't want to only do robotics. I just want to get people interested in making technology, taking stuff apart and making stuff. And I do not want to be constrained by the syllabus because the syllabus isn't a terribly helpful, in my opinion, thing with the way that people's minds work. We don't want to say, this term you have to do this because it's the syllabus. That's just craziness. So we have to allow ourselves to be much more free-flowing. Now our approach is very, very simple. We do little mini projects every week. They complete something, get a little bit of success. They get some handouts which tell them what they're going to do, and it'll have bits of just-in-time theory in there. So at the point you need to know Ohm's law, it'll tell you about Ohm's law. At the point you need to work out, how big a resistor do I want, it'll give you a hint about the calculation. So it's not a textbook with projects in, it's projects with fragments of textbook in when you need them, okay? So the model is very much try to make it an activity rather than a reading thing. What we do to get around health and safety right now is we build electronics on a breadboard. And these breadboards come from Maplin, and they are the greatest thing since sliced bread. And they cost £1.73. You can stick them together and make enormous panels of stuff, and the kids can cope. So I have one with the back ripped off so they can see what a breadboard is inside. We use the class PCs and a USB cable. That's what the school has to have, some PCs, and I take the USB cables actually. This is an Arduino, a little bit dark, but I'll wave one in the air so that you can kind of get some sense of scale here. So that's an Arduino. That's a microcontroller, and all you need in order to program it is a free piece of software and a USB cable. It's got the programming bootloader on board, so you don't need an in-circuit programming system or any crap like that. Okay? And these are £14. So my local school bought 5 of these because they thought, oh, Gary's such a nice guy and he's giving up his time. We'll buy the kids some stuff and they can do stuff with him. It's got a reasonable set of useful I/O systems, so it's got analog to digital converters, about 10 kilohertz sample rate, 6 PWMs, which we can use to drive motors and servos, or used as digital I/O, 6 digital I/O, which we can use to listen to buttons or drive anything we want. It's got I2C, SPI, and a UART on board. And the only other thing on here is this little chip here, which is a USB to serial adapter interface. from FTDI. So that's the little chip. It's autonomous if we want. We can just plug a battery in and run a program. And so one of the first things that we do is we make a little flashing torch, and then we disconnect it from the computer and put a battery in. It still works. So in the first session, they do the classic blink experiment with the torch. And at the end of that, they've learned how to write a C program, or use a C program, download into the system, connect up some bit of electronics, and they've pretty much never done anything like that in their lives. But it seems that 12-year-olds can do this because it kind of looks like a video game. Now, fairly important, I should point out, is down these edges are some female sockets. And so you just plug wires in. There's nothing fancy about this, just little bits of copper wire with insulation, stick it in, take the I/O systems out, and you're good to go. And it provides 5 volts, so you can hang all kinds of stuff on it. The other part of the jigsaw is you get this mind-bogglingly simple. So this isn't anything fancy if people use Eclipse or a professional development environment. This is stripped down to be as simple as possible. You type code in here, you press the does it compile button, and you press the download into my computer thing button, and that's all you need to know. There are about 60, 50 example programs that come with it, from a blink program up to controlling servos, controlling stepper motors, and all kinds of stuff. So there's lots of free examples. The whole IDE and the whole tool chain is free, and it runs on Windows, Mac, Linux, Solaris, and so on. There is no obstacle other than £14 and a USB cable for anybody in the world to get onto doing this stuff. And if you're fortunate and live in China, you can get these for about £8. Okay? The programming language is simplified C, which fills most people with shock and awe. But if you don't tell a child that this is really hard and it's going to scare the bejesus out of them, they don't know and they don't care. Because actually the library is so well designed that that is the entire program. That is the blink program. And so I get them to add more LEDs and make little patterns out of them. And they know no better, so they just kind of do it. I don't ever say, this is really hard. Adults are really scared of ever learning C. You don't say that, so they don't care, and they just do it. So I get 12-year-olds in 1 hour to do all of this. So this is the entire piece of electronics that they need, bar the sensors, I should add, to do a line follower. So we put a couple of LEDs on, and then we'll hook some motors in. This is just an octal driver, because an Arduino can't drive a DC motor directly, just little model motors. And we put LEDs on so they can see whether it's working or not, because I find that they blow lots of stuff up. But that's okay, because all of the bits on that board costs less than 35p. So I don't care, really. In fact, I'm really pleased when they break things, because then they know that it's okay. Otherwise, they seem very diffident. So that 2 DC motors and a couple of sensors, which cost about 70p, and we can make a little line-following autonomous robot. And so after about 6 sessions, that's about where they are. Okay? So I started doing this before Christmas with one bunch of people. They took to it like ducks to water, to be honest, 14-year-olds. I then tried it with some 15-year-olds, and they kind of did it, but they didn't want to spend their own time as much. So I've only got a half a dozen kids that turn up in their own time to do this sort of thing. But it's good because they're self-selecting volunteers, and they're kind enough to me to criticize the stuff I do without saying you're a crap teacher and I'm never coming again, which is good. So they come up with ideas, and they said, could we control the robot with an infrared remote control? And I said, yeah, I'll write you some code so you can teach it your remote control. So get the TV remote from home, take it off your parents, bring it into school, and then you can use your own remote control for this thing. And they thought that was pretty cool. Now, in truth, they can also go to the pound shop and get a pretty good infrared remote control for £1, which has about 40 buttons on, which is a hell of a big user interface to manage, and use that. Then one said, could we make a big display like those scrolling text displays that you see in shop windows? And I said, but you can't solder, and that's going to be about 800 LEDs. How about we try and make an electromechanical TV? And so what this lump of madness, which the design and technology teacher made, is a little electric motor on a wheel with a magnet and a Hall effect sensor kind of straps onto that leg. And this is a Sainsbury's profiterole dessert pot with some aluminium foil glued to it. And so what we've got is a spinning mirror, okay? But it's cleverer than that because it's canted. And so one facet of the mirror spins and we get one raster scan. And then the next surface is at a slightly different angle. So we get another raster scan at a different position. And then the next one at another position. Now, we haven't really figured out how to do all of the stuff, but we've got the timing. We can synchronize switching dots and dashes on. Use ultra-bright LEDs, which are about 30p, which are 20 candle power, which hurts when you look into the things. But for about £1.40, we can have a laser. So we could actually have a laser projector. And what we're really going to do is we're going to go to a 3D printing company called Shapeways on the internet, and we're going to make this. One of the technicians at the school is a dab hand with a SolidWorks CAD package, and so we can convert this into a real little finished thing with the holes for the magnets and all of that kind of stuff for a few pounds. So we can do these kinds of things. They're interested in making so they understood this idea of modulation, and they kind of got the idea that you could receive it and decode it, and so they said, could we make an infrared telephone? So we could talk to each other. And so we got this Arduino strapped to the side of our heads with a breadboard with an infrared receiver and transmitter, but we could talk to each other. And so that's our next kind of set of plans. I want to do an ultrasonic tape measure thing in order to get some more ideas of modulation across. I showed them a stylophone, which I built because you can modulate this. I made a 6-bit digital to analog converter out of resistors. It was an okay idea. They thought it sounded pretty crappy. After about the 7th happy birthday to you, they sort of, will you just switch that off, sir? So those are the things that we're doing right now. As I say, 4 or 5 sessions in school time, 2 sets of 5 kids, and they pretty much all got it. Well, no, they didn't pretty much. They all got it. They all made the basics work. Okay? One of the students, though, remarkable kid, he came in after Christmas. He'd never programmed. He'd never made anything like this. He ordered from RS the bits, and he came in after Christmas with a piece of hardboard with some geared motors bolted to it, and he'd made himself an autonomous robot. And he kind of go, my job here is done. You know, if I could get 10 kids out of that school to do those sorts of things off their own bat, I'd be pretty happy. Now, the key lesson that we learned is we need a robot chassis because that's actually quite difficult to make, and hence the reason that I'm working with Stuart with this Create stuff, because he can put together a special kit for me, which is a robot chassis. And so they can just slot it together, and we can use that thing, a couple of electric motors to tote this thing around. The other thing that I've done as an experiment is worked with Warwick University, who have student outreach program. And so I had a few students come with me, and they helped. So they got involved, and we're going to keep rolling that program and develop it into a few more universities once we've got the hang of it, so that universities can take all of this as an outreach program for their science, technology, engineering students, and go to some local schools and figure out that this is fun. And the kids look to students much better than some old fogey like me as role models. So, you know, you guys are a much better role model than I would ever be. In fact, it gets worse for me because I'm getting older. So this is one of the things. This kid actually has, he has a Lego Mindstorms, but he doesn't use the controller. But Lego is such a lovely thing for building structure. That's what he did. And he soldered it himself up a sensor carrying board down here. So this has the line sensors. And you just get some white insulation tape, electrical tape, and stick it down on the desk. He said, can I, sir? To the teacher, and the teacher said, yeah. And he put this thing down and down the desk. Boy's a genius. Boy's a genius. Observations. After-school clubs are much less constrained and they're self-selecting. So to some extent, I have much less of a problem with crowd control. Often, the teacher just kind of sits and eats biscuits and does his work for the next day. The big problem that we have, in a way, is the raw material for this. We can use Arduino programs as starting points, but in order to do the electromechanical bits, we kind of need instructions and guides, so that's something that I'm not terribly good at, quite slow at. It takes me a while. But the kids have great ideas. I was trying to teach them schematic diagrams, which they never get taught. And one of the kids just said, well, you know, where you've got those blob things that you tell us are the connections, why don't you just put the row numbers of the breadboard on? And I said, of course, I don't care which whole row you put in the breadboard. And he said, but I do, and if you just told me, I would do it, and it would work first time. And you kind of go, oh, kids are so smart. Boys are genius. The other problem is they can't solder, and the school is very nervous about unleashing an after-school club with soldering irons. You know, the new Star Wars movie comes out. Vroom, vroom. And so I've been taught a technique by Paul Gardner, who's a teacher in Coventry, which is the mini-oven soldering technique for surface mount. You do this. You buy a mini-oven, a 1.3 kilowatt mini-oven, which costs about £27. You buy a thermocouple from Rapid, which is a multimeter, so you get a really good digital multimeter with a thermocouple thrown in, for about £20, and about £10 of solder paste syringe. You get your circuit board, and I've done this on Veriboard. Squidge down the solder, get a magnifying glass or a child with good eyesight and a pair of tweezers, stick your parts down, and I can do 0603, and I'm a doddering old fool. Put the components under the solder paste, you bake it to 210 centigrade, you switch the power off, you count to 10, you open the door, and it's cooked. One of my colleagues from Micromouse in Birmingham said, that sounds hilarious, can we try it? And so this is the board that he'd produced for his Micromouse. So this is quite a small board, and this is a 44-pin pick. And so he just put 4 toothpaste rows of solder paste down, stuck his DS pick on there, and the other bits. We stuck it in the oven, watched it get hot, shone a torch in to make sure the solder was melted, switched the power off, and it worked. Paul Gardner tells me that he gets pretty much 100% success rate with children of 12 making surface mount technology. He uses 1206 components to make it a bit easier for them. He doesn't have all of the, he's just stabbing me with a soldering iron, sir, and I'm going to sue the school problem anymore, which is good. But he can actually make electronics that looks like real production electronics. If you take something apart, like your iPod, and look inside, it looks like surface mount. It does not look like through-hole electronics. And so the kids have a respect for this, because this is real electronics. It's not that silly stuff. This is like an iPod. So he finds that they actually are more interested. Bizarre. He can make smaller things. He doesn't need drilling, so the PCBs are cheaper. So he's taken some of his electronics designs, shrunk them down, reduced the cost, and the kids enjoy it more, and he gets a fabulous success rate. So this is what we're going to try next. We're going to see if a child can make a computer, make an Arduino, which I think are kind of quite buzzy. Right, so one of the things that I've been doing because of this, and Stuart Dunn, is working with the Open University, who are rejigging one of their programming courses. And what they want to have is an easier introduction to programming, but they want an external sensor system. So what I've done, is design the electronics in cahoots with the Open University. Now I'm writing the firmware for this little guy, which will be distributed to at least 4,500 people next year who take the OU programming course. And it might go up to 100,000 if schools adopt it, or more. And so every year people are going to get this little guy, and it's got some light sensors and sound sensors and wiggly little sliders and buttons. And this is going to show up within a programming environment from MIT called Scratch, which will be renamed Sense because they can't infringe on that trademark, and the OU are extending it. So this is a Sense board, and it's really an Arduino underneath, a chunk of firmware and some simple electronics. And it's got plugs and sockets on, so it can put more stuff on. It can drive a couple of motors, so we can mount it on a chassis, and this can drive around the room. So this is going to be small-scale mass-produced. So, amazing what happens when you get enthusiastic about things, isn't it? So my next little goal is, or was, wouldn't it be nice if we had a much more powerful tool than the Arduino, because its A to D conversion is pretty slow, and its digital to analog is PWM, it's non-existent. And Paul Gardner believes that if we could give some kids something with much better analog I/O, we could make a DIY pod. And so what we could do is give kids the ability to make their own iPods and choose what the hell it should do, and build its own user interface and put it in boxes. And so all we have to do is take something like that and shrink it down. Now this costs £25, but it's got lots of stuff on we don't need. So if we can shrink this down to this size, which absolutely you can, we could provide children with the ability to just accept a piece of working electronics, which is an iPod, and worry about packaging it up using modern 3D printing technology or whatever, and become packaging designers. Or they could investigate the software and go, this OGG stuff is much better than that horrible MP3 stuff, which has got all of these silly license constraints. We can just use this open source OGG thing that runs on everything, which would be nice. And they can play with compression, decompression. Or they can actually make one from components, because the parts on here cost less than £10 that are useful. So we think for about £12 we can put together a kit which we could surface mount solder in a little oven in the back kitchen, and people could start making DIY pods. So that's that thing. Now it happened earlier this year that I stumbled into an article in Nuts and Bolts or something about balloon sats. And I went into my friendly local neighborhood ex-colleagues at Black Pepper and started rambling about this. And Dave Johnson said, oh man, you need to talk to Kieran, and you need to talk to these Cambridge University spaceflight guys. And oh, really? Why is that? And so I did. As often happens, you know, you get these genius ideas. And so my idea was to just make a little balloon satellite using a little Arduino controller and put a science experiment on. Thought this would be fun. And started investigating it. I went to my local balloon shop, who is literally at the end of my street, and said, how much would you charge? And said, well, I could do a 80 centimetre balloon for about 12 to 15 pounds. I could do a metre balloon for maybe 20 pounds. What do you want it for? And I said, well, I'd like to make a balloon satellite for the school. And he said, you know, when it's a busy time of year, every week we get a helium cylinder back with enough helium in to fill maybe a 1 metre balloon. And I needn't charge you for that because someone's paid for it. And you know, if you're willing to take a brown balloon, because no one likes brown balloons, I can give you those. So if you could make a little harness for this thing, we could do it after work, and we could probably do it for, you know, nothing. So this is a good thing. So I went to talk to the school, and they said, we're up for anything. If it costs less than £100, we'll do it. Because, you know, that's a rare and unusual experience for the kids. We'll do that if you can get it under £100. And so the target is 1 metre balloon. Work out the numbers, and it appears that we need a 1 metre balloon will lift about 160 grams under perfect conditions. But, you know, we want to underfill it, we're going to make all kind of mistakes, blah, blah, blah. And so if our target payload is about 50 grams, I think we'll actually get off the ground. But we need an experiment, a recovery system, and the thing that really did it for the kids, I showed some 12-year-olds this, and I showed them that picture. And I showed them teddy bears in space. And several of the kids said, oh, that's really clever, how did you do that? And I said, well, you know, you fly a satellite. Was it Photoshop, or, you know, how did you do it? Is it, you know, because we can do Photoshop a bit. It looks very good. So, no. So I went to CU Spaceflight site and showed them the pictures of children doing it. And then they got it. And they said, oh, you're saying that we could fly something into space. And I said, not real space, but pretty damn good space. I mean, it's black above you, not because it's night. That thing really is the atmosphere, and most of it's below your feet. And they said, that would be really good fun. Can we have a camera? So that's a problem. How do you get in that 50-gram payload a camera? So I went to Argos, bought an Hitachi camera, stripped it down, and I've got down to about 40 grams. but this is just an off-the-shelf camera. So I think I might be able to do it with an off-the-shelf camera, but I'm completely happy to do something better. So I was planning on coming here and saying to you guys, will someone help me? Now, here's the smallest Arduino that you can buy. It's about the size of 2 postage stamps, and that with a coin cell weighs about 7 grams. So will you guys help me in order to make this recovery system? I was talking to CU Spaceflight, Fergus, last night, and he said, you want a recovery system? I got a recovery system. Sometime in the next few weeks, Fergus is going to have a recovery system that weighs about 20 grams. So we're pretty damn close. And I'm happy to run around and do the work and get the kids and drive around. What I'm asking you guys for is some help to actually track the thing, because I don't know how to do the radio bit. But if we can join these pieces together, what have we got? We've got potentially a extremely cheap, potentially free, because there are hundreds of balloon shops in the UK, and my balloon shop says most busy balloon shops every couple of weeks would be able to launch you a satellite for no cost of helium. So we could have hundreds of balloon-sat space flights a year, but what we need to do is get this so dumb and simple that we can hand it off to somebody else, like a student from a university, to go and organize and run for us. The experiment part was a real problem until yesterday morning. I was desperately thinking, oh, we could put a temperature sensor in or something. Well, that'd be boring. But you guys have got it. You're going to have a real satellite with an experiment on, and there's nothing to stop us making a little baby version of the same thing be the experiment on our balloon sat, and the children can see something in the classroom, they can go out in a field and launch it and get the data back, and then they can actually listen to a real satellite in real space, and they know how it works because they've done it. So I think there's a great opportunity, and the nice thing I think for AMSAT is you can kind of get double value. There's a way for the children to do it themselves and lock that idea in with what you're contributing in your space satellite. So I think there's a lot of fun stuff that we could do down this path. And as I say, I'm happy to go and do the grunt work because that's what I've been doing for the last year. But I will need some assistance. One of the things that you might be able to do is say to your radio amateur people who complain that they can't get into one of these nice talking to the space stations, why don't instead you go and launch a damn balloon and help the kids track it and recover it? You pick a week and talk to the local balloon store. So the last little piece is help. I need your help to build the micro balloon sat payload. I think Fergus has already stepped up and done his part. Man. We need to do a few practices, go out, track and recover this, see if we can shrink wrap it down to something that can be handed to competent people initially to go out in the field and do, so that, you know, maybe next summer, every week, somebody's doing it, and maybe you guys might even want to stick AMSAT on the side of the balloon, because as sure as eggs is eggs, my school will get the local newspaper down taking photographs of those kids with a chunk in the newspaper saying what the school is doing. That's what happened a couple of weeks ago when I even proposed this idea. So getting a message out to local communities around schools and school children, I think, is quite feasible. I don't mind if you guys don't want to help, because I'll just do it anyway as best I can. It might just take me years instead of months. There you go.
Okay, thank you, Gary.
Thank you.
Do we have some questions from the audience?
Or volunteers?
David?
Well, volunteered.
No, not volunteer.
Oh.
Certainly ideas.
Mm-hmm.
I've been playing around with closed circuit television cameras and radio varieties of this.
Mm-hmm.
And if you take the casing off, they're ever so light and ever so small. I'm just wondering if we can put one of these little cameras on board one of these balloons and transmit the pictures back live.
That would be brilliant. The school said, one of their first things was exactly that, and said, wouldn't it be really cool when we have sports day to have one of these things, because you can tether them up to 150 feet? Wouldn't it be cool to have this on sports day, watching sports day? You know, kind of like real international rugby with a balloon flying over the top or something. We could do that for ourselves. And again, the local newspaper will report that. All you have to do is stick your logo on the side of the balloon. So yes, let us do that.
I'll have a look at that. See what we can do, David.
Good idea.
We'll have a look at that. What have we got?
Some comments and questions from the web chat. First of all, congratulations to you promoted by AAC and IK1LDO from Denmark and
It's very kind.
you're doing excellent work, and probably the main problem is finding teachers like you.
Yes.
Then a technical question from the US, KF282TW, is how fast is the analog to digital conversion on the I/O board?
On the
Repeat the question for the
the analog to digital conversion on the Arduino is a limiting factor, and it's 10,000 samples, 10K samples per second, 10 bits. The other board that I showed you, which is based on an ARM Cortex chip, it's got dual analog to digital converters, and each one is a mega sample per second. So it's 200 times faster, or 200 times more interesting samples. Okay?
Another question. David, you again?
Yeah, it's me again. Where do we get hold of these boards?
A company called NewElectronics.com sells them in the UK.
NewElectronics.com.
NU Electronics, yeah. I mean, if you have trouble, just email me, which is gbulmer@gmail. It's the mail system for people called Gary. And I'm very modest. I'm not at all megalomaniacal. So if you have a problem, gbulmer@gmail, and I'll help you find them. But they are £14 including VAT. And we're going to see if we can design a surface mount version for less than a tenner, if it becomes relevant.
Thank you.
Do we have another question?
I'd like to sort of say something a bit more directory, I think.
Oh.
Which is, as somebody who worked in school for a year and a half and now working with BLA, it's really lovely to see something that doesn't make the kids into a marketing arm for Microsoft. And instead it's open to free stuff, open source stuff, and stuff that they can actually play with and understand how things work. The thing I noticed in school very quickly is that they do not have a clue how anything works.
Yes.
No matter how simple it is. They know how to manipulate things, and of course I agree that's an important part of growing up, but they don't know how anything works. And when we did some of the sorts of things you're doing now with our local scout group for
Good.
geotech. And it was great, but we found, I mean, you say there's a problem with the next generation of engineers, but we found in fact that some of the adults there, they couldn't help us, they didn't even know how to wire up a simple circuit with a battery and a lamp. And we found running all that with a crowd control, but you know, we managed. And we had them soldering, because we weren't in the school, so.
Yes.
And they were okay. Wonderful solder sculptures, some of them too. An artistic offspring. Anyway, that's it.
And just to sort of close the loop a little bit on that comment about not knowing how to do something, Stephen, the kid who went home over Christmas after, frankly, bugger all instruction and made his own working autonomous robot, he said to me a few months in, you know, sir, 6 months ago I didn't think you could kind of go out and buy bits of electronics and stick them together and make anything work. And it's really straightforward. It's much easier than I ever thought. And that, for me, just kind of pretty much sealed the whole year. You know, it's like, oh, okay.
There's two
Yes.
things. Engineering isn't cool, or perceived to be cool. Banking isn't, things like that.
Lawyers, psychologists, you cannot get onto a psychology GCSE in some schools because it's such a popular option.
The other thing is, as you said, teenagers is the lost generation. We concentrate on the very young, maybe, and the teenage bit before you take A-levels, whatever it is, when you've just forgotten. And it's nice to see someone doing something with kind of teenage or whatever, which can actually do things and all the rest of it. Anyway, let's show congratulations to Gary again for that. I appreciate that.
You're welcome. Thanks. Thank you for listening.